In the Part 2 exponent law video, we're going to look at some extensions of applying the 7 exponent laws that were from the Part 1 video. So this example has lots of parts to it. It has a numerator, in parentheses, raised to a power, and then one term in the denominator. So if we think of order of operations, we want to simplify the parentheses in the numerator first. So here we have 2ab cubed, all being raised to the power of 3. So that's 3 parts to that numerator that are all being raised to that exponent. So using the property of exponents, we are going to raise each of those 3 to that power. So 2 to the power of 3, a to the power of 3, and then b to the power of 3 to the power of 3. When we raise a power to a power, we multiply them. So that's b to the power of 9. And the denominator I'm going to just rewrite. Now we know that we can rewrite 2 to the power of 3 as 8. So I'm going to rewrite that as 8a cubed b to the power of 9 over b to the power of 5. Now the reason this is an extension is because we are not done. We notice that we have a b in the numerator and in the denominator. So if we're dividing like bases, the law says that we subtract the exponents. So that would become b to the power of 4. So we rewrite that as 8a to the power of 3, b to the power of 4. Here we only have one numerator. There's no denominator, no fraction, but we have 3 items being raised to an exponent. So here I'm going to cut out the second step that we did in Part A, because we know that 5 to the power of 3 is 125. So I'm going to go ahead and evaluate that. A to the power of 2 to the power of 3, we multiply a power raised to a power. And here we multiply a power raised to a power. Now the reason this one takes an extra step is because we do not like negative exponents. They are not simplified. So we want to somehow simplify this negative exponent, b to the negative 18. Well, if we recall our law, we can make that exponent positive as long as we move it down to the denominator. So we're going to move this to the denominator. Our final answer is 125 a to the power of 6 over b to the power of 18. Final answer. Now the last slide here, we're going to look at rewriting each of the following values as a prime number base. Now it may seem a little weird because each of these are fractions or decimals less than 1. Well, let's, at this first example, just look at the denominator. We have 4. We know that 4 can be written as 2 to the power of 2. So if I rewrite 1/4 as 1 over 2 to the power of 2, we end up getting a fraction with a prime number base in the denominator. Well, if I wanted to rewrite this as just a prime number base raised to an exponent, I can move this denominator, 2 to the power of 2, to the numerator as long as I make that exponent negative. So I could rewrite that as 2 to the power of negative 2. Now you may be thinking, hey, why would I do this? We don't like negative exponents. They're not simplified. Well, if we read the directions, they just want us to write it as a prime number base raised to a power, and we have done that. When we get into exponential equations later on this year, it'll be important to be able to rewrite that as a prime number raised to a power. So that'll come into play later on in the year. For now, let's just read the directions, and it doesn't say simplify. It says specifically to rewrite as a prime number base. So that's why we do that, and we leave it as a negative exponent. Let's do the same thing with b. 81 is the prime number 3 raised to the power of 4. So we know that that's the same thing as 1 over 3 to the power of 4. So we rewrite this now as a prime number base. If we move this up to the numerator, we get 3 raised to the power of negative 4 using our property of exponents. Now here, b, which of course should say c, the third example, we have 0.2. Now this isn't a fraction, but we know that 0.2 as a fraction is the fraction 1/5. So we already have a prime number in our denominator. So if we want to write this as a prime number raised to an exponent, if we move this to the numerator, we have to realize that that exponent of 5 is 1, 5 to the power of 1. So we rewrite that as 5 to the power of negative 1, and we have an equivalent value.